Well, in this episode, we're going to talk about making up a simple benchtop testing tool. And it will just simply be an ignition coil that will fire a spark plug, and the purpose of that is to test spark plugs out. So we'll call it a spark plug simulator. We're simply going to be able to, under no load, of course, and a no pressure condition. You can still use an air hose for doing some dynamic testing on it. But let's go ahead and get started on it. This was a real simple design. I built this many years ago and utilize it for either race applications or a situation where I'm really trying to isolate a specific problem. And now with the cost of spark plugs, it's probably not a bad idea to verify the plug itself doesn't have an internal related problem that you can identify by use of a simple, whatever lab scope you may have around. If you got one that's hooks up the secondary, all the better. Anyways, here's the components. I just simply took an old DIS coil. This was the one with the twin terminals on it. So some of you might, there isn't a lot of these around. Most everything's conventional coil on plug. But in this particular case, they're still available. If you had to buy it from the parts store, they're going to cost a few bucks. But a lot of used junk that are around. And then the easiest one I found was simply the old HEI ignition and some kind of heat sink. That's going to be key to the whole thing. So you simply mount the coil, go over here, and this is going to be your primary plus and minus to your coil pack itself. And then we got to come over to a triggering device. So let's go back to the hookup here for the primary. So this terminal here is simply going to be the ground side of the coil, or the triggered side. The other terminal here, and this is going to be our battery. So our battery's coming in to here. It branches at this point, so it's supplying power to the module, and it's supplying power to the coil. So conventional primary hookup. You got to make sure it has a ground. So I just simply ground to the body here. And I think that's what we want to talk about, the key to the whole thing. We need a means of triggering. I used to actually run a distributor and a drill. That worked. It worked fine. But this is so much more convenient. So you don't have to set it up on a simulator board like I have here for the demonstrations. You can make it up any way that works for you. You could actually just mount this right on your heat sink. Preferably use something steel that's going to be able to absorb the heat. This will get hot, and I'll demonstrate it here in a moment. And then you just pick up a little pulse width modulated driver, a little frequency controller. Readily available on eBay and Amazon for around $20. So they're inexpensive. You're not going to have a lot of money in this. So in this particular case, I have it set up there. I just went with a 30% duty cycle, just kind of a nominal number. And then I'm set at 21, in this case here, 21 hertz. I'm getting 2,500 RPMs. So I can actually work the spark plug and energize it, do all kinds of things to it. One of the things that I like to do, put a little air pressure across it, just small amount. You get to see the dynamic, you stress it. You can watch it on the oscilloscope, and you can get some analysis. Now, if you look at the wiring that I have actually hooked up here, on my ground side, the ground side here, I simply took a good quality lead. It was just an old meter lead that I had around, and put it to a spark plug terminal inside here, and it is pop riveted it to the clamp. And no, you won't get shocked. You're safe. And then a spark plug wire to the other terminal. Since we're completing a circuit through here, and we have a good, and this actually, the coil is going to do basically reduce any EMI effects. So it's going to, the spiral round will have a benefit on not giving any noise into your lab scope. So that's something to consider. So very simple configuration here. Now we haven't run it very long. But we're already getting heat. And I normally will shut this off. There's a fair amount of density to that steel, but she's climbing pretty quick. So if you want to run it for an extended period of time, I would suggest get a bigger piece of aluminum would work the best for this application. Well, hope this little technique was beneficial to you. I appreciate you viewing. Make sure you subscribe and comment. I thank you and have a wonderful day.